Okay, this is a recording for Bonding 1 tutorial. Okay, so first we look at the overview for bonding. Okay, so here I've shown you the difference between Bonding 1 and Bonding 2. Right, so basically we are going to study the giant structures and some things about the simple molecular structure. Okay, so I want you to take note that covalent substances can either have a giant structure or it can have a simple molecular structure. Okay, so it doesn't mean that a covalent substance definitely has a low melting point, for example. Okay, so if it has a giant structure like diamond, it also has a very high melting point. Okay, so for Bonding 1, we're going to stop at shapes of molecule. So this is also what you'll be tested up to for review test. Review test is only up to Bonding 1. Bonding 2 will be dealing with intermolecular forces. Okay, now we look at the Bonding 1 summary. Okay, so basically we'll be looking at the giant structures. We are going to learn about ionic and covalent bonds in greater details, more than what you have learned for O-level. And then finally, we'll be looking at shapes of simple molecules. So with that, we'll look at question 1, which is on the structures. Okay, so for this question, you have to give 3 things: structure, bonding, and 1 example. So for part A, element that conducts electricity. So from this, we know that it's definitely a metal. Okay, and usually metals will have rather high boiling point. So you can see for yourself here is higher than 1000 degrees C. So the structure is giant metallic structure. So bonding is obviously metallic bonding. Okay, and for example, you can give any common metal, but just don't give group 1 metals. Okay, because group 1 metals, they are different from other metals. They actually have rather low melting point and boiling point. Okay, so for example, sodium, which is in group 1, has an even lower melting point than sulfur, which has a simple molecular structure. So you can give group 2, group 3, or transition metals. Okay, part B, a solid with a very high molar heat of vaporization. Okay, molar heat of vaporization. Okay, this term means the amount of heat required to vaporize 1 mole of a substance. So it could be the amount of heat required to vaporize either a solid or a liquid. Okay, so essentially it's something like the boiling point of a substance. Okay, so here you are told that this solid has a very high boiling point and does not conduct electricity when molten. So this will tell you that definitely it's not an ionic structure. And because it has high boiling point, so it's a giant molecular structure. So examples will be diamond and silicon dioxide. So take note, graphite will not be accepted as an example because graphite is a conductor of electricity. Okay, next we look at hard and brittle solid that cleaves easily. Okay, cleaves is like breaking lah. Brittle means it's very easily broken. So this one is a characteristic of ionic compounds. Okay, we'll see why that's so. Okay, the reason is this. Okay, so imagine that this is the original structure with cation and anion alternating with one another. So let's say now we apply a force to this ionic solid. So like a shearing force in this direction. So what will happen is one layer will be displaced against the other layer. Okay, so it's being displaced by the distance of one ion. So you see what happens after displacement. Okay, the cations come into contact with one another. So you know that when ions of the same charge come together, they will repel one another. Similarly, the anions here will also repel one another. So it's this repulsion that leads to cleavage of the solid. Okay, so that's why ionic compounds can cleave easily. Okay, for the example, you can give any common ionic compound, but I want to caution you, don't give group 3 compounds. Okay, because later you will learn that certain group 3 compounds are covalent. Okay, even though we know that the group 3 elements, they are matters, so they should form ionic compounds with non-matters. Okay, but now at A level, you need to realize that not all the group 3 compounds are ionic. So just to give a common example that you need to know, like aluminum chloride is actually covalent, it's not ionic. Okay, next, part D, a substance that boils at minus 50 degrees C. So this means very low boiling point. Okay, and it's easily decomposed. So this will tell you that it's simple molecular structure. So for simple molecular structure, I want you to distinguish between the two types of bonding. Okay, so first you have bonding within the molecule. Okay, that means inside one molecule. The atoms are held by covalent bonds. Then in between different molecules, they are held by weak van der Waals forces. Okay, so the covalent bond inside the molecule is strong, but the attraction between the different molecules, van der Waals forces, are weak. So one example that you can give is hydrogen chloride. Okay, so if I use this as an example, okay, can you see that the bond inside each molecule, okay, is a covalent bond holding the atoms together. Okay, but the attraction between different molecules is weaker van der Waals forces. Okay, so the dotted line shows the weaker van der Waals forces. So be careful to distinguish between within the molecule and in between different molecules. Okay, one more thing, when we melt or boil the substance, we are breaking the van der Waals forces. Okay, we are not breaking the covalent bonds. So that's why simple molecular structure has low melting and boiling point. Okay, finally, a solid that flakes easily. So this one will tell you that the solid has a layered structure. Okay, so the only example that you should be giving is graphite. Okay, so graphite has a giant molecular structure. Okay, but here you need to distinguish between two types of bonding. So within a layer, the atoms are held by covalent bonds. But in between layers, they are held by weak van der Waals forces. Okay, so graphite is used in pencil. We make use of the fact that it flakes easily to write something with the pencil. Okay, so the van der Waals forces are very weak, very easily overcome, so the layers can slip over one another easily. So that's why graphite flakes easily. Alright, that's the end for question 1.